Alright, what is going on, guys, and welcome back to another video where we are going to practice our skills using the linked lists. So in this exercise, what we are required to do, what we are requested to do, is to write a function that creates a linked list. Okay, so the function should create a linked list. So basically saying the function should create this new list. Okay, these are the steps. Create a new list, receive numbers as input from the user, and every received number should be added to the end of the list. That's basically the flow of how the function is going to work. And the stopping condition in this case for the list will be when the number is -1. So would be when number is, let's say, is -1. And finally, what the function should do is return the new created list. So that's pretty much everything we have to do in this exercise. So once again, I've went over the steps quickly, one by one. Let's briefly discuss them once again. So first of all, we need a function that will create a linked list. Okay, then when the function we wrote it twice. Okay, so creating a linked list, receive numbers from the user as input. Okay, and at every time you receive a number, create a new node and add this number to the end of the list, add this node to the end of the list, and do so, repeat this operation until a stopping condition of -1 when the number received from the user is -1. So until this condition happens, keep on receiving numbers from the user and creating new nodes and adding them to the end of the list. Once the stopping condition is met, then in this case return the address of the first node, return the new list. Okay, that's all that we have to do. Okay, so now let's talk about the solution. So first of all, one more time, let's understand what we are being asked. We have a function. This function does not receive anything as an argument, okay, anything, because we don't see in the question anything similar to the phrase the function should receive and yada yada yada, right? So we'll assume that we will just have empty parentheses for this function, okay? And the function creates a new list. So this part we already know how to make, okay? Because we've seen in one of our previous examples how to create a new list. I think we've seen it, right? If not, that's a problem. We will see it right now, so no worries, guys. Then what we will have to do inside of the body of this function is simply to run some loop, okay, to get inputs from the user and add them to the end of the list. And if everything has gone smoothly, then the function should return the new created list, the first node in this list. Okay, so one of the questions that students like to ask me here is, why didn't we use an array to solve this problem? And actually, it's a very good question that I've been asked a lot. How come that we've always used arrays for these types of questions? Why should we bother to use linked lists now? And the answer for this question is very simple, because we do not know in advance what is the size of the inputs that the user is going to give us. That means we don't have any idea how many numbers we are going to receive from the user during this process. It may be 10 or it may be 10,000. So how can we create an array, okay, of just some fixed size if we don't know how many elements we are going to get? You got the idea, guys? And we know that a linked list is an easy way, an easy structure that we can use to expand. We just have to add a new node And there you go, you got yourself some new element added to your data structure. You have expanded your linked list. But that is not the case for arrays, okay? Although you can do something very tricky by using this realloc function for a dynamic array, but still these operations are much less efficient. So that's the reason why we will use linked lists for this question instead of our well-known arrays. So I hope that's clear to you guys. It's very important not only to get some hands-on, but also to understand what is going on behind the scenes and how we can use it for our advantage, and also to prove that our solution will be good enough, and also to be able to answer the question, why didn't you use something else? Okay, fantastic. Let's start coding, right? That's time to some coding. And the first thing we are going to need for this question is defining a new type of structure, our node. Okay, so let's define our node, and we know that it can be the same node as we used yeah, I think I added this video in previous examples. So, but if you're not familiar with that, so let's use typedef struct node. Okay, so we're creating a new struct called node using this typedef, which we already also discussed. Okay, and now we are going to fill in the fields. Okay, so the first field is going to be, let's say, int data, and the second field, okay, because we are talking about nodes in this linked list, we know that from one node we should be able to access the next node using some pointer. So this pointer is going to be of struct node, right? Because we are going to point to the next node, and the next node is of type struct node. So next is the name of the field which will contain and hold a pointer to the next node in this linked list. And also we are going to specify here node, so that whenever we would like to create a new node, we will know that we can use node, and it will be struct node. Awesome, guys. So now let's write the main function, not the main function, but the function that we are interested in. And we know that this function should return a linked list. So the question is, should it return just node, or should it return node star? So take a second and think about it. And once you are done thinking about it, think to yourself is why node is not enough. Because node, for some reasons, it may be good, okay? I don't think I will cover up in this video, but what we want to do is to return the address, okay? The address of the first element of this array. I'm not talking about all the details behind the scenes, because we would have to talk about copying a value and by value, and the copying or what happens behind the scenes. But what I want you to understand is that it's much better here to just return the address of the first node, and then in the main function, when we are going to receive this address, we are simply going to get this address, when we know that from this address on, we have our first node, and we know how to access the next node, and so on. So node star, and let's say create list of numbers, okay? This will be our function. And this function will not receive anything, because why should it receive something? It will create a list and return it. Okay, so now what we have to do is to create the head, so node star head, and we created a pointer, and this pointer name is head, okay, and what it will has to do is simply point always to keep the head of the linked list, because we in some situations, if we move this head, we will not be able to know what is the head of the linked list. So this head will simply always point, always keep the head of the linked list, okay? So we will always know from what point the list starts. Okay, so now let's use also additional variable, additional pointer, current node. Okay, so current node is simply a variable, that holds an address where resides some node. And I will explain you guys exactly why we will be using it. And it's simply basically we will use different iterations, and we will use like knowing where a new element should be added to. So this current node will simply point to the last node we've been working with, and once we want to add a new node, we will know, okay, so I don't have to iterate from the head to the last node that we have, but I know that the current node holds the last element for this function, and I should add this new element from there on just to save some time and efficiency. Alright, so now what we are going to also to add is an integer number, int num, and this variable is simply where we are going to store each time the number received from the user, the actual data. So let's run some commands. So printf, please enter a number or -1 to finish. Okay, and once you do so, let's read this number using the scanf function. So %d and put it inside num. Okay, and if num, okay, if the first number was equal to -1, so basically we shouldn't even iterate any further, then simply return null. Okay, so very good, guys, and now let's proceed. What we also have to add here is the head. Okay, the first pointer equals 2. Okay, so what we do here is that we assume that num at this step, okay, we assume that the first num was something legit number, okay, some legit data, not -1. Okay, so if that's the case, we need to create a node for that, and we know that the first node will be for the head. So we know that we will allocate using some malloc function and use here size of node. Okay, so we're allocating a new node and putting the result, the address from this malloc function to head. So head already points to a new created node, and we also will say that current node equals to head. So basically at this initial step, it's outside the loop. Current node and head will point to the first created node. All right, so now let's use current node data. Okay, current node data equals to num. So simply we know that previously we just allocated it. We allocated the memory, but it was not initialized, and the field of data will be initialized with the number num received from the user. Okay, so that's pretty good. And now what we want to do is simply taking, what do we want to take? We simply want to take additional value, okay? Additional value, so let's just copy these two lines. Please enter a number, oh la la la, okay, no problem. That's what we will do. And now we know that we at least have one node, so we can iterate using while loop. As long as num does not equals to -1, as long as our stopping condition has not been met, as long as we haven't reached our stopping condition, so as long as this while loop happens to be true, then we are going to run its body. So its body says the following thing. So current node, it's basically the last node that we are pointing to. At the field of next, okay, which should point to the next node, which is currently just uninitialized value, right? We do not point anywhere from here. We should allocate a new, okay, because we received additional number here, we should allocate a new node. So that's how we allocate a new node. Let's copy that. Okay, so we allocated a new node. And what we also want to do is to move forward the current node. So current node now points to the previous, to one before the last nodes that was just allocated here. So we allocated a new node. We know that the next field points to there, and we want current node to point to the last one. So current node dot next. Okay, there you go. So current node at this point points to the last element, and that's awesome. What also we want to do is that we know that we created this new element. We know that we need to specify the current node data. Okay, so the data should be equal to num, right? We created this new node. Okay, first of all we received some number. We made sure that this number does not equal to -1. We created a new node, added it to the end of the linked list. Okay. Then we said, let's move also current node to point to this new allocated node. And also we will say that current node, right now it's the last, it's the new one, it's pointing to this one. Let's say that its data will be equal to num, right? We filled it up, pretty simple. And now we know that one iteration is over. Let's read the values for the next iteration. So printf, please enter a number or -1 to finish. Okay, guys? So that's what we do, and we read the value using the scanf function. So percentage num, ampersand num. Okay, and now we go again and again and again and again. We run over this loop, adding nodes to the end of it, keeping up with this simple analogy. My suggestion to you guys is take a piece of paper and just draw at least 1-2 cycles of how it's being added. So create this first pointer, create this second pointer, they do not point anywhere, then read one value from the user, run this logic behind the scene and kind of draw a new node created. Say that head is now pointing to there, and also current node pointing to there. Update the data, read additional number, okay, fill step by step to see the whole picture of what is going on behind the scenes, and then run the logic of this while loop one after another, iteration after iteration, and see how it looks like, even, like visually. It will help you a lot, it will give you some practice, it will help you on your task at work, on your tasks at work, or even on your exams. It will reduce pressure, and it will, don't jump right away to code, and don't say you understand everything. Try to draw a little bit and to proceed from there. Okay, I know that a lot of you will not do it, but I still take my chances. So lastly, guys, we know that we have the current node, and at some point num is equals to -1, and we leave this function for good, and we leave this loop for good. And last thing that we know that the last created node has some data, some legit data, and it also has some field of next which is uninitialized, and we want to indicate that the last node in the list ends here, and there is no other place we can move from this point on, and not to make some memory access violation. So what we are going to do is to specify that current node point next. Okay, that's the last node, and the field next will be equal to null, and this will simply let us know that it's the last element. And finally, what we will do is that we will return the head, because it points to the head of the list, and we know that this list can be navigated only in one direction, and this navigation can only start from the head. So current node, thank you for helping us out. Now we need to return the head of the list, which is the address of the first node in this list, the address of the first node in this list. Awesome, guys. Whew. I think this was a really tough exercise, but I think it covered up so much. The creation of a new linked list and returning a new linked list to whatever and whenever we would like to use that. Probably in our future examples we will also use it. So I think that's freaking awesome. Once again, if something is not clear, feel free to repeat this video, to view it one more time, to write your notes down, and if still you have any questions, feel free to ask them in the frequently asked questions. Maybe somebody asked a similar question before. Take a look there, and this will help you to learn more and also share your knowledge and your questions with other students. So as always, guys, thank you so much for watching. That was an important video, and I will see you in next videos. Have a great day and great practice.